In 1964, communications theorist Marshall McLuhan wrote, "The medium is the message." This refers to the how of what we consume being more informative than the what. Or, in Marshall's own words, the content of the medium is a message that can be easily grasped, and the character of the medium is another message which can be easily overlooked. But at the time, McLuhan was speaking about the mediums of radio, television, and print. But to McLuhan, a medium wasn't just the book or the TV show. It's any technology that extends our senses into new observations and awareness. But it is not much of a stretch to see this statement extended into today's connected world of the internet, e-commerce, cell phones, and social media. But one important lesson that I took from studying McLuhan over the years was that he did not intend for his statement, "the medium is the message," to be a static sign, ignored all night like a traffic light, but to the contrary. He urged us to continually reflect on its meaning, usage, and application in our rapidly changing world. My name is Frank Blau, and I'm a data architect living in Western Austria. And I'm here today to demystify using this idea when thinking about data architecture, the domain that my career has been based on. That is, the creation, storage, and retrieval of data to provide not just insight, but actionable insight. So my first narrative is going to be a little about the data mediums that we play in today, but I promise I'm not going to give you a long technical lecture about data architecture. So let's start at the beginning. If we think of a business, there are transactions, that is, unique pieces of data that represent something of value that happened. It could be something simple, such as purchasing a book or food, or even accessing educational content or entertainment. But to store the relevant details of transactions, the majority of use cases are based on a relational database. That is, we create large tables of information that relate the relevant data, such as customers, products, and purchases. Tables are related using unique keys to identify rows in table and relate them to each other. But in this pattern, or as I call it, a narrative, we want to know what happened, and we need it to be accurate, timely, and available. Putting data into multiple related and structured tables of data is the core of a relational database. Now, this is all well and good. Our business is successfully able to function without the transactional model, within the transactional models that we are using. But eventually, someone wants more insight. Say, how much beer was sold to males between the ages of 18 and 25 on the weekend in Vorarlberg, where I live? Spoiler alert, a lot. But if your transactional relational database is large, these kinds of queries can be difficult to create, maintain, and manage. So two clever guys, Ralph Kimball and Bill Inman, developed the Relational Dimensional Model, or STAR schema, that organizes relevant attributes of the data around the transactions so that mere mortals, or the marketing department at least, can interrogate the data to explore their insights. To create this, though, we would typically develop a nightly process to extract the transactional data, transform it, and load it into the new dimensional models. But an important characteristic of relational databases, both the transactional ones and the dimensional ones, is that they are dependent on a schema or a structure of the tables and their attributes that does not easily change over time. This immutability of the schema is partially what allows them to be so reliably transactional. But this does come at the expense of flexibility, as you will see. But from just these two narratives, and I did trick you into learning a little bit about data architecture there, You can already hear the echoes of McLuhan's claim. That is, as we have adapted our medium, the database, to inform new messages, the needed actionable insight, we've adopted this to make the medium match the message. But there are other data narratives. If you think about a pressure sensor inside of a machine, where a nightly process of review of that information might be very interesting, if the data is coming at you very rapidly, like millions of times per second, then the usage of this data can't wait until the next day. Oops, we blew up the machine last night. It might be actionable, but it is hardly a prudent use of the data. But while the relational database may excel, and that's not a pun, at managing tables of related data, it was not really designed to accommodate this high velocity data. So a different narrative or architecture was needed. This led to the time series database, where very small records of typically just a timestamp and a sensor value were stored so that data could be visualized and acted on in real time. The data architecture, again, the medium, evolved to tell different stories, the message inside of our data. In this case, when did something happen? So this would all go along nicely if it weren't for the pesky applications that we were writing to use this information. For these applications, it required a lot of complex access methods to retrieve something as simple as, tell me everything you know about a customer, regardless of where it lives or where it comes from. This would mean the ability to not just render the orderly relational data, but also the sometimes messy and unstructured data like phone logs, web pages, and even binary data like images and audio. For these patterns, a document model was developed that stores relevant data about a customer, for example, into a single document with the ability to edit and append it as new sources of information become available. Document databases come with massive scalability, including the possibility to manage millions of documents while still providing real-time access to their content. But also important in a document database is that the schema or structure is only optionally enforced, giving them a lot of flexibility with regards to growth and usage. Again, the medium of the data architecture informs the message. Show me all the relevant data in one place. Now, this next medium gets a little bit weird. Coming from the world of linguistics and semantics, where interestingly, McLuhan spent much of his academic career, where these are called resource data frameworks, or RDF triples. So what is a triple? Well, if you think of a fact in the data, Frank Blau was born in Santa Barbara, California, as having three components. A subject, Frank Blau, a verb or predicate, was born in, and an object, Santa Barbara, California. While those components may be very simple, it quickly becomes apparent that just about everything we describe in data can also fit that pattern if you take the time to parse it out. For example, TEDx22 is in Dornbirn, or Frank Blau lives in Dornbirn. But what distinguishes this pattern is that now the relationship is in, lives in, between things itself has meaning. Importantly, you know from reading the triple the exact meaning of it. By contrast, in a relational database, I would have to explicitly create an attribute that meant this holds the value for the place the person was born. And you would have to know what that relationship meant by looking at the multiple tables. But also imagine your person or system that is putting data in the database. It would have to know specifically where, what format, etc., that the data had to be in, and then would have to find that record to insert or update it. And the existence of an attribute may tell you nothing about the usage or origin of that value. With a triple, the content is self-contained and self-evident. You just read them without having to know anything about them in advance. But another cool thing about them is that there are millions of examples of triples that are available online for use today. One example is the DBpedia dataset, where they have created triples for all the facts contained in Wikipedia. This means that if I want to know who all the people born in a place with a certain climate are, I can use the DBpedia triples for city has climate, always sunny, to match to the city of Santa Barbara, California in my database of triples and aggregate information about the people who have been born there. I also have the ability to store properties with the elements of these triples in what's called a property graph database to make it much more friendly to people who are used to seeing objects with their data. These models give us access to many rich observations about the data that you do not get from relational databases, time series databases, or document databases by themselves. And we store this information in what's called a graph database. And while it's a topic for a much larger speech, think of a graph database as a way of putting all your triple data into a model that leverages the interconnected insight that they offer. Examples of this graph data include things like LinkedIn, where you can see not just who you know, but who you might even find people or someone who knows someone that you know. Or Facebook, where it is not just your friends that have value, but also the friends of your friends from other social connections like work, school, musical interests. But the easiest way that I like to think of this is that a graph databases are capable of not just telling you what and when you know a fact, but they can tell you how you know it also. This rich insight sets this medium and its messages apart from the earlier models. So now that you've been told about some different interesting mediums and their possible messages, how can you leverage this information in your business or even in your life? As you probably realize, it is a rare business that has a requirement for just one of these models. Most businesses have at least more than one source of these insights. You may, for example, have a relational CRM application, a dimensional data warehouse, time series DevOps logs, and document-based application interfaces all over the place. Considering these forms together is what we call a multi-model architecture. And if we are truly to bring to life the wisdom of Marshall McLuhan's statement that the medium is the message, then we should start with acknowledging the obvious premise that our multi-model lives and businesses require multi-model solutions if we want to represent them accurately. The good news is that there is a mature marketplace for both open source and commercial solutions on which to create a multi-model platform. But before you choose one, and it may quickly devolve into very technical issues and topics, there is still an important place for asking the question, what is the message or narrative that I'm seeking, and what models can best uncover it? And asking it of your business users, not just the technical nerds like me. This will illuminate the places in your business and data management strategy where your data narratives exist. And you can leverage a multi-model architecture using already available tools and platforms to gather these stories together. So we've talked about relational, dimensional, document, time series, and graph databases of several flavors. and how they each have their own narrative message, which is derived from not just the content. This evolution from schema-bound transactional databases to more flexible, semantic-based approaches will be an important trend in the coming years. In particular, the ability to have interoperable systems across multiple models will provide significant competitive advantage to those businesses that can make it happen. This multi-model approach is also, I believe, the future of both my career and enterprise data architecture. But exploration of what mediums or models are best suited for your story still starts with asking, what message or narrative am I trying to communicate, and plumbing together those mediums to enable the discovery of actionable insight within them. This will enable not just recognized content to be leveraged, but it also uncovers the value of the underlying structure and its importance to the design and adoption of a meaningful data architecture, capable of informing you and your business across multiple models and use cases, but also one that takes advantage of Marshall McLuhan's approach to investigating the claim that the medium is the message.